All right, so what you see here, you remember when we were going through these parts, we had a lot of different X, Y, Z. You noticed I kept moving those around. So here's one for op 1. So you'll see we wrote X and Y are at the center of the part, and then we wrote our Z is this distance above our parallels. So in this example, when we put the material in the vise, we'll have to set our tool based off of, say we have our vise, we put our parallels in the tool, and we'll set the height of our tool right off the parallel. And once we know what that number is, we'll lift it exactly 1.1875 and hit 0. And now, anytime we put a piece of metal on the parallels, it'll cut every part so that when the parts, no matter how thick the parts are, when they come out of the vise, they'll all be the same height. So that's what this is for. And you'll note as we go through op after op after op, all this stuff changes. And man, I'm not going to lie, I spent like, 6 hours doing this or something, just making this sheet. It's like this page and that page. Man, this math stuff, this is a lot of math and a lot of doing numbers. There's so much that goes into this. For example, one of the hardest things about building stuff like this is your material doesn't always come in at the same size. Sometimes it's a little thicker, a little thinner, and stuff like that. And you need a program where you can just run your parts, and no matter how big the material is, when you put it in for this first op, like if I have 10 parts, all 10 parts are going to have a different thickness when they go into this operation. And that's just going to be how it is. That's just the nature of saw cut material. However, when all the parts come out of this last operation, they all have to be the same. And that's the challenge, is you got to build the system, as they say. That's, it's just part of the business, right? So yeah, we've been working on this. And we finally got some numbers. I'm probably going to take tomorrow off. My brain is cooked from doing all this stuff. But this is the plan. I think our plan now, this is all built around having 4 3/4 material. So I think our next steps, we're going to have to take the material we got and go machine it down to be 4 3/4. And then I'm going to take one of those, put it in the machine, and basically these programs I showed you, these operations 1 all the way down here to 13, I'm going to export these programs, put them on a jump drive. I'm going to take this, type it up, and print it out. And essentially, this is kind of like your play-by-play of how to set the material up. And so what I should be able to do, without knowing anything, I should be able to walk up, take a piece of material, stick it in a vise, do what this says, which is, set your Z at this height and set your X and Y at the center of the part. And when I'm done with that, I should be able to click cycle start on op 1 and the machine work. It should not crash. It should not break a cutter. And when I get done, it should, machine that base properly. And then I should be able to go here for the next 3 ops. I just center up on the part and put the new tool in. I should probably have a note of what tool goes here. That's important, actually. But then I would set my Z to this number above the parallels. And again, hit cycle start and it should run. So actually, while I'm explaining this, I can already see I'm missing tools and I'm missing probably a picture of which way the part goes in the vise. That'd be pretty important. So I'll probably do all that. But essentially, you get the idea. We're kind of creating a playbook to where once this book is wrote, you don't have to remember anything. You don't have to be like, oh yeah, I know that's op 5. I got to use this tool. Or I know I have to set my offset a certain way. Or I have to remember to add 100 thou to that dimension or whatever. Essentially, you're doing all the work, getting the answer, writing it down. And when I go to the machine, if I've got, say 20 parts to make, then I can just, do this, put the first part in, hit cycle start, and then do this, put the second part in, cycle start, and just go, go, go. Just keep following that and it should work. And that's why we did this, because the caps that I've showed you guys, I can't remember if I mentioned this, maybe I did, but those caps took like 8 hours to make, and they're not even finished. They look like a cap, but when you look at this, the caps I showed you guys are not the correct thickness. They're too thick. They don't have this tang, and they don't have holes. And these flats are not the perfect dimension. It's really just the shape, and those still took like 8 hours. If I had actually finished them, there's no telling how long it would have took. So that's a huge thing, is, getting this process figured out, because, I wanted to see if I could make the part. And once I did, I was like, okay, well, I can do it, but now I got to come up with a system to do it efficiently. And so that's what we've been working on. But yeah, I wanted to show you guys all this, and hopefully that adds some clarity to what we're working on. And as we actually start following this, I'll definitely show you guys how that goes. Anyway, hope y'all enjoyed, and y'all take it easy.